At a kitchen table in Columbus, Ohio, in August of 1977, a man flipping through computer printouts stopped cold at 6 characters buried in a wall of numbers and grabbed a red pen. He circled them, wrote a single startled word in the margin, and without meaning to, an unpaid volunteer created the most famous unexplained record in the history of the search for extraterrestrial intelligence. The word was wow. The characters were 6 EQUJ5. Together, they described 72 seconds of a radio signal that came out of the sky, hit a telescope in an Ohio field, and vanished. It was loud. It was focused. It was broadcasting at almost exactly the one frequency scientists had predicted an alien civilization would choose. And in nearly half a century of looking, no one has ever heard it again. This is the story of the WOW signal, what actually happened, what it wasn't, and why it still keeps astronomers up at night. To begin, forget flying saucers. Picture instead the summer of 1977. Star Wars is packing theaters. In Florida, engineers are bolting a golden phonograph record to a spacecraft called Voyager. And in the farmland outside Delaware, Ohio, stands one of the strangest instruments ever built, the Ohio State University Radio Observatory. Everyone calls it Big Ear. Big Ear doesn't look like a telescope. It looks like a drive-in movie theater built for giants. 2 enormous metal reflectors facing each other across an aluminum ground plane bigger than 3 football fields. Its designer, the engineer John Krause, built it in the late 50s and early 60s to map the radio sky. And it did that brilliantly, cataloging thousands of radio sources nobody had ever recorded. But by the 70s, the money was gone. Congress had cut the funding. The paid staff scattered. And rather than let the giant die, a handful of scientists turned it toward a stranger question. In 1973, Big Ear began listening for signals from other civilizations, full-time. It would eventually be recognized as the longest-running SETI program in history. The telescope could not steer. It stared at one strip of sky and let the Earth's rotation drag the heavens past its beam, like a lighthouse working in reverse. Anything out there, a galaxy, a quasar, a transmitter, would drift through its field of view in exactly 72 seconds. An aging IBM 1130 computer with a tiny sliver of memory listened on 50 narrow channels and condensed each 12 seconds of sound into a single character on a printout. 0 to 9, then letters for anything stronger. A blank meant near silence. Most of the paper came out blank. One of the people reading that paper was Jerry Ehman. He had been on the project back when there was money. When the money vanished, he stayed on as a volunteer, taking stacks of printouts home and combing them line by line, week after week, for years. It was unglamorous, eye-glazing work. Radio astronomy at a kitchen table. On the night of August 15, 1977, a few minutes past 10 o'clock Eastern Time, Big Ear's beam was drifting through the constellation Sagittarius, the direction of the heart of our galaxy. Nobody was watching in real time. The computer simply did what it always did. It listened, it counted, it printed. A few days later, Ehman sat down with that stack. And in Channel 2, in one narrow column, he saw a vertical string of characters unlike anything the telescope had recorded in 4 years of searching. 6, E, Q, U, J, 5. Here's what those characters mean, because they're not a message and they're not a code. They're a volume knob. Each character records how strong the signal was during one 12-second slice, measured against the background hiss of the universe. A 6 means 6 times stronger than that background. Letters climb higher. U, the peak, means more than 30 times louder than the noise floor. Nothing in the entire survey had ever come close. 6 characters, 12 seconds each, 72 seconds exactly. The signal rose smoothly, peaked, and faded in a perfect bell curve. Precisely the pattern you'd expect if a steady source fixed among the stars drifted through Big Ear's beam. Not a flicker, not static. Something that behaved, in every measurable way, like it was out there, parked in the sky, transmitting. And then there was the frequency, 1,420 megahertz. To radio astronomers, that number is almost sacred. It's the hydrogen line, the natural hum of the most abundant element in the universe, a wavelength of 21 centimeters. In 1959, physicists Giuseppe Cacconi and Philip Morrison published a famous paper arguing that if an alien civilization wanted to be found, this is the dial position it would choose, a frequency every scientist in every galaxy would know. The cosmic watering hole. Big Ear was tuned there for exactly that reason. The wow signal came in a whisker above the hydrogen line, squeezed into a band so narrow, less than 10 kilohertz, that nature struggles to produce it. Stars, gas clouds, pulsars, natural sources smear their energy across wide swaths of spectrum. Narrowband signals are what transmitters make. So Ehman circled it and wrote, "Wow." And then he, John Krause, and project director Robert Dixon spent months trying to kill it. Was it an aircraft? Planes move. A plane's transmission wouldn't rise and fall in that perfect 72-second curve locked to the rotation of the Earth. A satellite? Same problem. And besides, the band around 1420 MHz is protected by international agreement. Nobody on or near Earth is licensed to transmit there. A ground signal bouncing off a piece of space debris? Ehman himself worried about that one for years, but the physics never quite worked. The reflector would have to move in lockstep with the stars, and the protected band made a terrestrial source unlikely in the first place. An equipment glitch? The hardware was checked and checked again. Nothing was wrong. Then there's the detail that keeps this story genuinely strange. Big Ear listened through 2 feed horns, side by side, aimed at slightly different patches of sky. As the Earth turned, a celestial source should have passed through one beam, then the other, roughly 3 minutes apart. 2 detections, a matched pair. The wow signal shows up in only one. And because of how the computer logged its data, no one can even say which horn heard it. Either the source switched on and then off within a span of minutes, or it was simply gone by the time the second beam arrived. A steady beacon shouldn't do that. A rotating beacon, sweeping past Earth like a lighthouse, might. So might a transmission deliberately pointed at us for only a moment? That is speculation, and honest astronomers say so plainly. But the one-horn mystery has never been explained away. The obvious next move was to look again. Big Ear went back to that patch of Sagittarius dozens upon dozens of times in the following years. Nothing. In the decades since, the hunt became almost a pilgrimage. The astronomer Robert Gray made it a personal quest, searching with the Meta Array, then in the mid-90s with the Very Large Array in New Mexico, an instrument sensitive enough to hear something hundreds of times fainter than the original, and later with a radio dish in Tasmania that stared at the region for hours on end. Silence. Every time, silence. Searches have continued into the 2020s with modern instruments and modern algorithms. The sky near a faint group of stars called Chi Sagittarii has never said another word. That silence cuts both ways, and it's worth being honest about it. A signal that appears once and never repeats can never be verified, so it can never be evidence of anything. That is simply how science works. But the silence also strangled every mundane explanation. Interference tends to come back. Glitches repeat. Whatever this was, it happened once, cleanly, at the magic frequency, in the exact shape of a celestial source, and then never again. There was even a reply. In 2012, on the signal's 35th anniversary, the Arecibo Observatory in Puerto Rico beamed a response toward that region of sky, a digital bundle carrying thousands of crowdsourced messages from the public. It was as much publicity stunt as science, and everyone involved knew it. But there was something quietly moving about it. 35 years late, humanity finally said something back. In 2017, it briefly seemed the mystery had died. An astronomer named Antonio Paris proposed that a pair of comets, unknown in 1977, had been passing through that region of sky, each wrapped in a cloud of hydrogen gas that might have hummed at the hydrogen line. Headlines around the world declared the wow signal solved. The astronomy community pushed back hard, and this part is not really debated anymore. Comets don't produce strong, narrowband emission at 1420 MHz. The comet in question doesn't appear to have even been inside Big Ear's beam that night. and a huge, diffuse gas cloud can't explain a signal that hit one feed horn and missed the other. Members of the original Big Ear team publicly rejected the idea. The comet theory made the front pages. Its rejection mostly didn't. Other ideas still circulate, and they deserve honest labels. One researcher identified a sun-like star sitting in the signal's search box, an intriguing target for follow-up, and nothing more than that. In 2024, a team combing through old Arecibo data proposed that a rare astrophysical flare, perhaps from a magnetar, might briefly light up cold hydrogen clouds and mimic a wow-like event. It's a serious, testable hypothesis. It is also, so far, exactly that, a hypothesis. The truth is that after nearly 50 years, there is no accepted explanation. Not aliens, not comets, not interference. Nothing has survived scrutiny. And here the story turns quietly heartbreaking. Big Ear itself is gone. The land beneath the great aluminum ear had been sold to developers. And in 1998, the telescope that heard the most famous maybe in scientific history was torn apart to make room for an expanded golf course and housing. The longest-running search for intelligent life ended under a bulldozer. Jerry Ehman kept the original printout safe for decades. That page, with its red circle and its startled word, now rests in an Ohio archive. Ehman himself never became a believer, and that restraint is exactly why people still trust this story. He spent decades poking holes in his own discovery, and he liked to warn against drawing, as he put it, vast conclusions from half-vast data. But after ruling out satellites, aircraft, ground reflections, and broken hardware, even he conceded the possibility he could not close, that for 72 seconds, an instrument built by hand in an Ohio field caught something artificial from somewhere that was not Earth. Think about what those 72 seconds actually were. That's not how long the signal lasted. It's how long Big Ear was physically able to listen before the Earth's rotation carried the beam away. The signal was already there when the beam arrived, and still there when the beam left. It could have been transmitting for an hour that night, or a year, or 1,000 years. We caught the sliver we happened to be positioned to catch. Once, with a nearly broke telescope and a computer running on borrowed time. And we have never been positioned quite right again. The wow signal is not proof of alien intelligence. Every careful scientist who has studied it says the same thing. It is a candidate, the best documented, hardest to dismiss candidate ever recorded, and nothing more. But late at night, it's difficult not to sit with the other half of that sentence. On an August evening in 1977, hours before the world lost Elvis Presley, days before Voyager left Earth forever, the sky spoke at the one frequency we always said it would. Clearly, briefly, exactly once. We wrote, "Wow," in the margin. And for nearly half a century, we have been listening to the silence, wondering whether someone out there is still waiting for an answer. If you want more forgotten history that sounds made up, but isn't, subscribe, and I'll see you in the next one.